Let's look at integration of trigonometric functions. Okay, again, as usual, it would be very easy if we know the derivatives of these functions. Okay, you will see as we go along. The first one is minus cosec square x dx. Now, we should know that minus cosec square x is the derivative of cot x. So, cot x plus c. Okay, second one, integral of minus sec square x dx. Here, we don't require this minus sign, so let's take it out. So, sec square x dx. And we know that the sec square x is the derivative of tan x. So minus tan x plus c. Okay, third one, integral of minus 2 cosec x cot x dx. So minus 2 we can take it out. We have cosec x cot x. Now here the thing is, we know that the derivative of cosec x is minus cosec x cot x. But since we have taken minus out, let's bring it back in cosec x cot x dx. We should not forget. So this is cosec x and plus c. Fourth one, integral of minus 4 sine x dx. Again, we know that constant we can take it out. Now, we know that the derivative of cos x is minus sin x. So, which means we can take this minus in. So, minus sin x dx. So, the integral of this is cos x plus c. A fifth one, integral of 3 sec x tan x dx. The derivative of sec x is sec x tan x. So, this would be 3 sec x tan x dx, which means 3 sec x plus a sixth one, integral of 4 cosec square x dx. Now, we know that the derivative of cot x is minus cosec square x. Right? So, what we'll do is 4 we will take it out and we'll make this as cosec square x dx. And here also we'll put it minus, so that minus minus plus it becomes. So now we have minus 4 cot x plus c. Is seventh one, integral of 3 cos x by sine square x dx. Okay. Now here, what can we do? Let's take 3 out. Let's split this sine square x. So we write it as cos x by sine x times 1 by sine x dx, which means this is nothing but cot x times cosec x dx. And we have already seen that this is nothing but minus cosec x. So we can write it as minus 3 cosec x plus c. Okay. Eighth one, integral of minus 5 by cosec x dx. This can be written as minus 5. Now 1 by cosec x is nothing but sin x. And we know that sin x is the derivative of minus cos x. So we can write it as minus cos x. So this becomes 5 cos x plus c. Ninth one, integral of minus 4 by sine square x dx. minus 4 comes out, 1 by sine square x dx. We know that 1 by sine square x is nothing but cosec square x. Now we require minus cosec square x because minus cosec square x is the derivative of cot x. So let's make this minus and this plus. So we get 4 cot x plus c. So as you have noticed, the better we know the derivatives, the easier it becomes to do integration. Okay, integral of minus 4 by cosec x dx. So again minus 4, integral of 1 by cosec x is sin x dx, and sin x is the derivative of minus cos x. So that becomes 4 cos x plus c. Okay, 11th one, integration of 4 cos x by sine square x. We have already seen this. So 4, we can write this as cos by sine is cot x, and we are left with 1 by sine. So 1 by sine is cosec x dx. This is the derivative of minus cosec x. So this becomes minus 4 cosec x plus c. 12th one. Okay, integration of 5 tan x dx. Okay, we can write this as 5 tan x dx. Now this can be written as sin x by cos x, right? So we need to do a little bit of additional work in this case. Let's look at the denominator. Let's say u is equal to cos x. So that means du by dx is equal to minus sin x. That means we can write du in terms of dx. So minus sin x dx. Okay. So now this can be rewritten as sin x is what? Here we have dx. Sin x dx is what? This minus we can bring it to this side. So we have minus du. And cos x is what? U. So this becomes minus, we can bring it out, 1 by u du. And we know this, right? So minus 5 natural log of, remember, absolute value of u plus c. And finally, natural log, and we bring back the u. U is nothing but cos x plus c. Okay, 13th one, integral of 5 by sec x dx. 1 by sec x is nothing but cos x dx. And cos x is the derivative of sin x. So find sin x plus c is the integral. Okay, 14th one, integral of minus 3 sin x by cos square x dx. So minus 3 integral of sin x by cos x times 1 by cos x dx. Minus 3 tan x sec x dx. And we know tan x sec x is the derivative of sec x. At the 15th one, integral of sec x dx. Okay, now this is a bit tricky. You have to look at the derivatives of various functions of trigonometric functions and see where does this sec x appear, right? It usually appears in sec x and tan x, right? So what we can do is do something like this: sec x, something like rationalization. So we multiply by sec x plus tan x and divide it by sec x tan x dx. Now, why are we doing this? Because when we multiply it out, we get sec square x and sec x tan x, right? So now if you look at this, if we do this, what happens? Uh, let's say u is equal to sec x plus tan x, right? Now if we differentiate it, we get du is equal to sec x is sec x tan x, and tan x is nothing but sec square x dx, right? So if we differentiate the denominator, we get the numerator. That's the idea. Here we can substitute this sec x. Okay, we need to distribute it off so that we get clarity. Sec square x plus sec x tan x by sec x tan x dx. Okay, so what is the numerator? Sec square x plus sec x tan x. That is du with the dx. So we can write the numerator as du, and sec x tan x is u. So this is nothing but 1 by u du, and we know that this is natural log of absolute value of u. So which means we can now do the substitution with u. That is nothing but sec x plus tan x plus c. So this is the integral of sec x. Okay. Now 16th one. Integral of 5 cosec x dx. This can be written as 5 integral of cosec x dx. Now something similar to the previous example. Cosec x usually goes with cot. So let's see. Let's multiply both numerator and denominator. Here if we say denominator is 1 by cosec x minus cot x. So cosec x times cosec x minus tan x. No, cot x divided by cosec x tan minus cot x. So what is the advantage of this? Let's say u is equal to cosec x minus cot x, right? Then du would be what if we differentiate this? Cosec x is nothing but minus cot x cosec x, and cot x is nothing but minus cosec square x dx, right? Which means this becomes minus cot x cosec x plus cosec square x dx. Now that we have done this part, now let's proceed. I missed this 5. So let's say 5, and let's expand this off. We get cosec square x minus cosec x cot x by cosec x minus cot x dx. Now, here if you notice, we can do the substitutions. Cosec square x minus cot x cosec x is nothing but du along with dx, right? And cosec x minus cot x is u. So which means this is nothing but natural log of the absolute value of u. So which means we can again substitute back u, which is cosec x minus cot x plus c. So this is the integral of 5 cosec x. 17th one. Integral of minus 2 by cos square x dx. So minus 2, 1 by cos square x is sec square x dx. And we know we know sec square x is the derivative of tan x plus 18th one minus cos x by sin x dx. So if we take u as sin x du becomes cos x dx, right? So which means we can write this as cos x dx is du by u. So that means what? This is natural log of absolute value of u, which means it is minus natural log of sin x plus c. Many times what happens, when we look at these absolute values and lot of these symbols, we tend to get confused. But the thing is, it's pretty simple. At every stage, you should know the prerequisite. What is required to learn that? So what you should already be knowing. That's it. Bye.